Hello everyone, I would like to show a solution for the chapter 4, not chapter 4, but test number 4 review, which of course this one just covers the last couple of chapters that we've been dealing with, namely chapter 10 and 11. So number 4 is asking, it says, suppose you want to test the claim that the population mean is greater than 25.6. So since we have that kind of a situation, greater than 25.6, really we're looking at the mean is greater than something. This would be, of course, a right-tailed test. And if we were going to actually set about to make this null an alternative hypothesis, of course, the null one would go that the mean is equal to 25.6, and then the alternative, which determines that this is a right-tailed test, would go greater than 25.6. So this is looking like some type of which kind of test? Of course, the type of test is determined by which parameter we're talking about. And since we're talking about the mean, this should be a t-test, is the one that we're thinking of. Now it says, given a sample size of n equals 58 and a level of significance of alpha equals 0.05, when should you reject the null hypothesis? So of course the test statistic, what it's talking about, because all of these answers are saying reject if the standardized test statistic, blah, blah, blah. Now the standardized test statistic, this has nothing to do with this mean that we're talking about, the 25.6. That's not related to the standardized one. The standardized one is going to be, of course, if you think to the word, when standard has come up before, like the standardized normal distribution, it's the z value if you're talking about proportions, and it's the t value if you're talking about means. So in this case, we're looking for the t value. There's a particular t value when we're going to reject the null hypothesis. And if we think about what a t distribution looks like, of course, it's kind of like this normal distribution, and it's a right-tailed test. In particular, we want the area in the right tail to be 0.05. So we're wondering, if this area is 0.05, what is the t value right over here? And the t distribution, of course, it's symmetric about 0. And we have to look up this value in a chart. We have those tables that are in the back of the textbook. I pulled up one. It's not the one from the book necessarily, but it's just an example of one of these tables. They all work the same. And it has to do with the sample size, because remember, with a t distribution, the sample size is very significant. The larger the sample, the more the t distribution will resemble a normal distribution. And so this one is related to the degrees of freedom, where the degrees of freedom, if I remember correctly, you can check this one. It should be one less than the sample size. So our degrees of freedom should be like 57. But if you ever pull up one of these t distributions, the degrees of freedom are these numbers that are going down the left side. So going like 1, 2, 3, 4, 5, blah, blah, blah. They max out somewhere. This one maxes out at 30. But you'll notice that between 30 and basically whatever is the ultimate value, it pretty much, they're really close together. So we know that the t statistic, it should be, we'll just use this one. Since our degrees of freedom is too much, we can just opt for the last value that's on the table, which in this case is going to be, we're looking for the column that corresponds to the level of significance that goes 0.05. And so 0.05 following it down, that's the value 1.65. So that's actually the appropriate t value for this one. This goes 1.645. So if our test statistic that we calculate is inside of this critical region, means it's anything more than this, if we're greater than this one, then we should reject the null hypothesis. So 1.645, that goes with C. We would reject it if the standardized test statistic, is such a tongue twister, is greater than the 1.645, which is the value there. So I hope that one makes sense. Thank you guys for watching.